explain to you really quick how to put everything together that we've been talking about for pretty much the last week. Um, it comes from input, output, independent, dependent, T-charts, scatter plots, lines of best fit, how to plug in functions, all of that. It incorporates everything, okay? So basically what we're talking about here is we're taking a T-chart, and it's number 15 on your packet, which it might be a different number depending upon what packet you have, but we're going to complete this T-chart, okay? So we drop something from 20, I'm assuming feet up. Yeah, it looks like it says feet here, so it must be feet. 20 feet up, and it bounces 15 feet up. Drop from 30, it bounces 24. So our job, first of all, let's start by finding the independent variable. So what's the input? And if you understand input and output, independent, dependent, you basically have the drop height, okay? And usually we don't put the word drop in there because it's an adjective. We just put height. But since we've got bounce height as well, they're both heights, we have to put drop height and bounce height, okay? So obviously, if you drop a ball, it's going to bounce. Now, it depends on the kind of ball, how much it bounces, but in this chart, in this experiment, we've got all the information there in front of us. So the independent, you drop it, or the control variable. The dependent, the output, is the bounce height. I'll abbreviate that. Okay, so we're dropping it, it's bouncing. We need to graph the following points and draw a fitted line. So go ahead and draw those dots if you have not yet. I got to figure out how to make dots on here someday. Anyway, there's 2015. So you should be doing this with me, and if I'm boring you, you should skip ahead and get to the point where I have it done. It's like a dot-to-dot graph. It's kind of boring, huh? 56. Nice thing is it's not very hard. Okay, so there's my dots. All right, so what I'm going to do is I'm going to shoot, I learned how to do this too, but I can't. We got to do a line of best fit. Now, before I draw a line of best fit, I always ask myself about 0. What happens at 0? Does it go through 0, 0? Does it go through 0, 10? Like, what does it go through? Well, in this case, if you think about it, it's an experiment. We dropped something and it bounced. So what if we drop it from a height of 0? What do you think it's going to bounce? Well, obviously the correct answer would be 0. If you don't drop it, it won't bounce. Independent, dependent. So 0, 0 is going to be my other order pair, Shazam, and at that point, alright, I had to pause really quick. Anyway, we're now ready to connect our lines using a line of best fit. Now, this is what I just had to go ask Mr. Weber about. Nice little tool. You start, kind of figure out where you want it to be. It doesn't necessarily always have to go through there, but I want to make sure that it does go through 0, 0 because that makes sense for this graph. So let go, bang, and there we go. We got a line of best fit. It's too bad it's a dotted line. It should have been a solid line, but here, let me do that. There we go. Solid line, even better. Okay, so we got our line of best fit drawn. At that point, it's kind of nice. We now have a line that we know we can find out any value. Say I told you that the ball bounced 50 feet. You can go up here to the bounce height and say 50 feet. Well, you must have dropped it from about 60 feet. So that's kind of a nice, easy way. Hey, the ball bounced 35 feet. I'm like, okay. So you come up here and you're like, oh, you must have dropped it from about 45 feet. Okay. So anyway, that's kind of nice. So what if I asked you how high does the ball bounce if you dropped it from 75 feet? Goes 75 up to the graph, over. You bounce back about 60 feet. Now, that's kind of nice for the nice small numbers. What happens if they get big? Well, we then need to have an equation. So, next step is write an equation. And the equation, if you remember, it starts with y equals always. In this case, our y is b, so we're going to start with b equals. Okay? We now have to figure out what's the common difference. So what happens each time along the way here? So it goes from 15 to 24, it adds 9. 24 to 32 and a half, adds 8 and a half. 32 and a half to 41, that's like 8 and a half again, If you don't believe me, get your calculator out and do these. I can do them in my head pretty well because I'm good like that. What is that? It'll be 7.5. And 48 to be 7.5 again. So they each go up, well, 7.5, 7.5, 8.5, 8.5, 9. What do you think is a good average? Some people would say 8.5, but you know what? A lot of people say 8, and I go, why? Why would you choose 8? Because look, not a single one of them are 8. And actually 8 is the best reason, because if you take this 8.5 and this 8 and this 7.5, they average out to be 8. If you take this 7.5 and this 8.5, they average out to be 8. So basically you got 4 numbers here that all average out to be 8, and then 1 extra 9. So that 1 extra 9 basically moves it up one little notch, probably be 8.1 or something like that. So what I'm going to do is I'm going to go with 8. I like 8. It's a great average. So we take 8 times the D, which is the drop height, and then we go plus blank. And the plus blank comes from the number with the 0. So what's with 0? It'd be 0. So I'm glad I found 0, 0 for this graph. So there's our equation. B equals 8D plus 0. So I'm going to take a quick little break here again. Let you get caught up. Okay, we're back. Alright, so now we have what looks like our line. Bounce to be 8 times... Wait a second. The bounce is 8 times the drop? That doesn't really make any sense. So what if I plug in 30? I know my answer should be about 25. So if I plug 30 into this equation, 30 times 8, that doesn't equal 25. I feel like I got something wrong here. And if you remember back to yesterday, you look at the change over here, and we decided it was 8. Alright? But look at the change over here. It's not going up by 1. It's going up by 10. It's going up by 10. So our answer actually is, our equation is bounce height is 8 over 10 times the drop height plus 0. I'm not even going to include the plus 0 anymore, so let's just get rid of that. Okay? So it's 8 times the drop height. 8/10 times the drop height. So I'm going to take this equation, I'm going to reduce that, and I'm going to call it bounce equals 4 over 5 times the drop. So now if I put 30 in here, what's 30 times 4/5? And if you use your calculator, or you can just take 30 divided by 5, is 6 times 4 is 24. Does this look like about 24? Absolutely it does. So now this is a better equation. This is correct equation, I should say, right here. Alright, so now we've got our bounce height. I wonder, would this thing highlight? Oh, it just covers it up. Anyway, I don't want to do that. We got our bounce height equation. Oh, geez. I gotta learn how to use this thing. There you go. Bounce height equals 4/5 times the D. Final question says, if I dropped a ball from a building that's 150 feet tall, how high would it bounce? Well, now that we have an equation, it makes it super easy just to plug 150 into our equation. So what's 150 divided by that 5 would be 30. 30 times 4 would be 120 feet. Okay? So now if you think back to do this whole problem, entire thing again, start with your input and output. Understand what's going on. Okay? We graph our scatter plot and draw a line of best fit, or a fitted line. Then we figure out our change here in order to figure out part of our equation. That's the change in the y. Okay, then we come over here and say, oh, the change in x is happening too. So that's 10. 8/10 times the drop height. Once you got your equation, you're ready to answer anything you want about the whole equation. Sorry that was so long. Enjoy. Bye.